Hello students, this is Professor here and I am back with you another video class, and today we are going to study about LCM. Okay, so in the previous classes we studied about the HCF. Okay, so now today we are going to study about the LCM. Now before starting you should know what is LCM. Okay, so let me first ask you one question. What was HCF? What was the meaning of HCF? And I am not asking about you the full form. Okay, so obviously HCF means highest common factor, but what was the meaning of that highest common factor? So actually it was, suppose if I am trying to find the HCF of two numbers or HCF of three numbers, so HCF of those number means the highest number which divides all of them. Okay, means we are finding the greatest number which divides the given numbers without leaving any remainder. Okay, so now lowest common multiple is just opposite of that. Suppose if I ask you to find the LCM of two numbers, that means the lowest means obviously smallest number which is divisible by the given numbers. Okay, so the smallest number which is divisible by the given numbers means, suppose I am giving you the example. If I ask you to find the LCM of 2 and 3, so what does it mean? It means you have to find the smallest number which is divisible by both 2 and 3. For example, you can see 6. This is divisible by 2. This is also divisible by 3, isn't it? So this is 1. Suppose if I say 12, see 12 is divisible by 2. 2 6 is 12. 3 also divides 12. 3 4 is 12. Similarly 18, isn't it? 2 divides 18. 2 9 is 18. 3 divides 18. 3 6 is 18. But which one is the LCM? LCM is 6, because we are trying to find the smallest number which is divisible by both 2 and 3. Okay, so this is the meaning of LCM. So now like in HCF, LCM, to find the LCM we have two methods. Okay, and the name is same. Number one is prime factorization method and number two is the division method. So no doubt we'll first do prime factorization method. Okay, so that means we are trying to find the LCM of two or more numbers with prime factorization method. Okay, so now without wasting time, let us find the LCM of 72, 90 and 108 using prime factorization method. Okay, not division method, we'll use prime factorization method. Okay, so for that obviously we have to prime factorize all the numbers separately. Okay, so I'll start with 72. So if you prime factorize this one, so how much will you get? With 2 36. This will again go with 2 18s, again with 2 9s, again with 2, oh no, not with, now with 3 is a 9, isn't it? So now 3 1s are 3. So 72 equals to how many? 1 2 3 3 2s, that means 2 into 2 into 2 into 2 3s, 3 into 3. So this is for 72 obviously. So now next we will do for 90. For 90 we will prime factorize it. Okay, so with 2 45. So now you can see it will not go with 2, isn't it? So now next we will try with 3 15s. Okay, again with 3 5s. Now with 5 1s, right? So now what will be the prime factorization of 45 then? Sorry, 90 then? It is 2 into 3 into 3 into 5, right? Isn't it? So next is 108. So for 108 obviously we'll do with 2 first. 254 again with 227. Okay, so next with 3, because 27 will not go with 2, so with 3 9s again with 3 3s, now with 3 1s. So 108 is prime factorized as 2 into 2, then 3 into 3 into 3, right? Now till the prime factorization part, it is same like HCF, right? So now, but to find the LCM, the first part is similar as the HCF. Okay, LCM equals to, okay, so now first what I will write, okay, see, now these 3 2s are same in all the numbers, so 1 2 will come here, isn't it, into next. So anything else? Yes, we have 3 in all the terms, right? So that is 3. Now after 2 into 3, we have to see, is there any number which is present in all the 3 terms? And I can see 3 is there. 1 3 2 3. 3 is here. See, means here, here and here. So one more 3 will come, right? So now, so apart from 2 into 3, you can see one more 3 is there in all the terms. Okay, see, 3 3 3. That is why I have written one more 3. So 2 into 3 into 3. So this is gone. So these 2's are gone, this 3's are gone, and this 3 are gone. So now next, what is your target is, you have to see now there are no such numbers which is present in all the 3 factorization part. Okay, we have done till there like we used to do in HCF. Now in LCM, what is different is you have to see other remaining numbers also. So remaining ones, from remaining ones, first you see which numbers are present in any 2. For example, here 2 is here, 2 is here, from the leftover part. Okay, from leftover part, I am saying leftover. Okay, so 2 is here, 2 is here. So this 2 will also come, only 1, but out of this 2 only 1 will come. Okay, so now this is also gone, this is also gone, right? So now next, now which one is remaining? Now this 2, this 5, this 3, this 3. Okay, so now is there any number which is present in any 2? No, this 2 is here, but 2 is not here, 2 is not here. 5 is only here, here also we don't have 5, here also we don't have 5. Okay, so now this 3's are gone, so 1 3 is remaining here. Okay, so what are the remaining numbers? 2 5 and 3. So this remaining numbers also we will write, that is 2 into 5 into 3. Okay, so how much will you get? So now the LCM is the number obtained by multiplying all this. So if you multiply all this, you will get 2 3s are 6, 6 3s are 18, 18 2s are 36, 36 2s are 72, 72 5s are 360, 360 3s are how much? 1080. If you multiply, you will get this as your LCM. Okay, so LCM is 1080. Okay, now to make you more clear, let us proceed to the next number, that is exercise 3.4. we will do sum from question number 1 A. Okay, so A is 54, 70. So here we have only 2 numbers, so it is quite easier than doing for 3 numbers. Okay, so for prime factorization, what will you do? First prime factorize this number. So 227, right? Then again with 3 9s, then with 3 3s, then with 3 again, 3 1s. So 54 is equal to how much? 2 into 3 into 3 into 3. I am doing the prime factorization part quickly, as I believe you know how to prime factorize the numbers, right? So first 70, how much? With 235s, right? Next with, I believe, is 5, because with 3 also it will not go. So 5 7s. Now with 7 1s. Okay, so 70 is how much? 2 into 5 into 7, right? So now in this case, first LCM equals to, you have to see which one is present in both. So this is 2, so only 1 will come here. So now, is there any other number which is present in both? No, right? So 3 is here, 3 is not here, 3 is here, 3 is not. So 5 is here, 5 is not here, 7 is here, 7 is not. So what will you do? You will write all the remaining parts, remaining numbers. That means 1, 2, 3. 3 3s are remaining. So you will write this one. And what are remaining? What else are remaining? 5 and 7. 5 into 7. Okay. So what will be our answer? 2 3s are 6. 6 3s are 18. 18 3s are 54. 54 5s are, I believe it is 270. Right. 277s are how much? 0, 49, 4, 14, 1890. So this is your answer for question number 1A. Okay, so this was for 2 numbers, so it is quite easy. So I want you to try question number 1B. Okay, so now to make you more clear, now we'll go to the next number which contains 3 numbers. Okay, so number C. So it is 28, 50, 134. Okay, so how will you do it? Now you will again prime factorize its numbers, right? So for 28, 2 14s, isn't it? So again with 2 7s, so now with 7 1s. Okay, so 28 can be written as 2 into 2 into 7, isn't it? Next, for 50, so for 50 already 2 with 2 25s, now with 5 5s, then with 5 1s. Next, for 134, right? So for 134 it will go with 2 6s, 2 7s. So now 67. Now 67 will be divisible by which number? So that you have to check. Okay, so now if you see 67, it will be divisible by I believe 50 is 2 into 5 into 5. So 67 I believe is a prime number. Okay, so it will only be divisible by 67 only. So 67 ones are 67. So 134 can be written as 2 into 67. Okay, so now next what we will do is, now we will find the LCM. Okay, so LCM is, first you will see the numbers which is present in all 3. That is this one, 2 2 2. So that is 2. You will write it here. So is there any other number which is remaining, which is there in all 3 factorization part? No. So now you will see which of the numbers are present in any 2. Is there any number? No, there is no such number. Okay, so now you will, after doing for 2, now you will write all the remaining numbers. So all the remaining numbers are 2 into 7. From here it is 5 into 5, and from here it is 67. Okay, so if you multiply all this, then you will get the answer. Okay, so I want you to multiply all this and find the answer. Okay, and question number D also I want you to do it as your homework. Okay, so in question number D, there are 4 numbers, but no need to worry. Okay, do slowly factorize each part. I am giving you a hint. Okay, factorize each part. Okay, and write all the factorization. Like there will be 4 for 26. It will be 1 here, 78 something, for 106 something, and for 200 there will be something. Okay, so now what we will do, first you will see the numbers which are present in all the 4 factorization parts. So you will circle that and you will write in the LCM. Okay, then after that you will see, after finishing for all 4s, you will see the numbers present in any 3. Okay, so for that also you will write only one. Suppose 2 is here, 2 is here, and 2 is here. Okay, so but 2 is not here, then what will you do? But they are present in any 3, right? So for this 3 also you will write only 1 2 here. Okay, and after that, since here are 4 numbers, you will again see the numbers present in any 2. For example, 7 is here, suppose 7 is here, then you will write only 1 7 in the factorization. Okay, and next what will you do? Then after checking for any 2, then you will write the remaining numbers. Okay, you will copy all the remaining numbers and then multiply, you will get the LCM. Okay, so this is how you will do the LCM by prime factorization method. So I want you to do your homework, number D and number B, only 2 homeworks, and you have to do. Okay, and in the next class we will do the LCM by the division method. Okay, so please do your homework and submit it in time. Thank you.